Morning, everyone. For those who don't know me, I come from the Portuguese Open University, which is Universidade Aberta in Lisbon. And my talk is going to be about mobile learning and new trends, but this in the context of blended learning, which is more than some of our universities are doing, because I'm in a very specific distance education university. What I'm concerned with is the changes that are taking place in our society. You can see probably the image that is on the slide. This is the classroom today. I think in many countries, not really in my country, but when I was in the United States in 2009, the classroom looked like this. Lots of students, maybe 150, 200 students, each one with a laptop or a communication device. And that means that 10 years later, students are bringing smartphones and tablets, and they are connected through the network. And maybe what we need is a seamless classroom. The learning doesn't take only place in the classroom, so it makes sense that we connect all these devices and the technology we have to learning. Luciano Floridi is a research scientist in Cambridge. He says something very interesting like this. ICTs are not mere tools, but rather environmental forces that are increasingly affecting us. For instance, blurring the distinction between reality and virtuality, and blurring the distinction between human, machine, and nature. Of course, this is a very useful concept, especially if you think about what's happening in the United States or in some countries where we talk about the post-truth and the post-communication and something that we don't really know if it is true or not because of the way the communication is done through the networks. It's not very easy sometimes to get grips on the validity or the quality of the communications we have. However, it's worthwhile for education that we use what society is using. And in fact, if you think about educational technology, according to the EU, the initiative Opening Up Education, it says that between 50 and 80% of students in the EU never use digital textbooks or exercise software or podcasts or games or simulations for learning purposes. So this is very intriguing because Europe is, in general, quite developed and very creative in the area of the new technologies. And in education, this is not happening. Although we see our students with devices, with smartphones, and in education, we still are a long way. We have to change this. So my research has been going around what's happening in classroom learning. How can we extend this onto online learning and all the affordances that we can get on through B-learning and go to mobile learning because of these devices that our students and teachers are using today. We can have something called a seamless environment. Seamless means that there are no barriers, no frontiers. Everything is connected and learning occurs through these virtual spaces as well. So this makes mobile learning prospects very interesting. This is the main topic of my talk. And this is where I've been researching for a long time now, maybe 15, 12 years. If you think about mobile learning, there are 4 ways you can do this now in a practical way. The basic model is basically SMS, MMS, images and text. This is what was happening maybe 10 years ago. Then we have responsive web design, which means that the materials, the resources are accessible via a web browser, and this can be adjusted to the different kinds of devices and screen sizes. Then we have educational apps, the apps that we can install in our devices, and these apps are sometimes very sophisticated and very fit for education. Think about Duolingo for learning a language, for example. Then we have educational ebooks. This is something I've been researching as well. Why not use ebooks that are interactive? They have multimedia, video, some animation, some kind of programming. And we can use ebooks in an offline environment with these portable devices, like we were in a classroom, and students probably could use this very easily. This is more or less, in this slide you can see more or less where we are going, what I call ubiquitous learning, which is a seamless environment that extends from the classroom to the e-learning on the network to mobile, and then everything will be connected. If you think about the Internet of Things in the near future, the fridge to the washing machine, everything will be connected and exchanging information. And in terms of education, what will happen is that our devices will also be exchanging information. Our teachers can send us the grades, they can send us information about assignments. Everything will be very easily connected, and anytime, any place, we can get access to this information. If we look at the research, this is a graph that goes from 2000 to 2012. The research on mobile learning has been increasing constantly. In 2000 there were less than probably 100 papers, and now into 2012 there was close to 7,000 papers, and now probably 8,000 or 9,000, I don't really know. But this is to show that is increasing the research in mobile learning, which is important. It is a trend that is established. In our institutions, in some of our open universities, we've been also researching with Moodle Mobile that enables students to access the Moodle platform anytime, anywhere. They can do it from a smartphone or any small device. It is not so sophisticated as the learning platform on a desktop, but is very supportive of activities and is easy for students to get involved in a discussion, for example. This is a question that I put myself, and we've been researching through these two areas. Shall we go for apps or for ebooks, or shall we use just the web as a means of interaction? This is a project. MILAGE Learn Plus is the app, but the Erasmus Plus project is called MILAGE, and this project deals precisely with the use of an app that can be installed in Android or iOS. You can go to this site, milage.walge.pt, and you can download or get access to the app. And the app is for learning mathematics, for students to interact with the resources, to solve exercises, and have a very interactive environment where they can learn mathematics through solving exercises. There are 3 different levels of difficulty, like in a game. Very easy entry level, and then there is an advanced level. And the student can start practicing and getting points and discussing with colleagues, like in a game. And we found this to be very interesting. Now we have 1,000, maybe more than 1,000 students involved with this environment that we created in the project. So this is an app, but the question is, shall we use native apps or responsive web design? Native apps are expensive, and responsive web design is very easy. We just have to make the web product friendly or ready for mobile screens. Otherwise, we have to invest in developing a mobile application. The advantages of the characteristics of responsive web is it requires an internet connection, which is not true in some situations. Might have a poor performance because of the browser limitations. As you know, the browser sometimes creates some errors of formatting. Formatting might not be very precise. Lack of natural navigation, lack of push notifications, lack of other functionality. This because the web design is limited somehow. But if we go for a native app, internet connection may not be necessary because the app is self-contained. Everything goes into the device. might show better performance, especially if the app is prepared for that, that operative system, increased functionality, enhanced security for users, brand awareness and accessibility. But all this comes with a price, so as you know, developing of apps are high investment of time and money. It takes time, and it has to go through many iterations to get it right. So we've done this app for the MILAGE project because it is a EU project and we had the resources, but it's not easy just to decide and go that way. Coming back now to education. As you know, we are now in the age of connectivism, if you wish. We think about connected learning with three different areas. Formal area, that this is where the courses are, with all the where the learning platform has all the official documents and the interaction. Then we have the informal area, where many apps or personal learning environments can be used. There are some examples on this slide. And then you have a social interaction area. It's not just Facebook, there are lots of other ways to interact among students and with teachers and the other colleagues. So these are the three important areas. Based on these models that we've been studying for some time, maybe 2-3 years, I joined with my colleague Ellen Roosman from the Open University in the Netherlands, and we decided that we needed a new model that could accommodate for these recent changes. So we start looking at some older models, for example, like Johansson's from 1988. And the Johansson matrix is about time and space. It's a very simple way of allocating the activities. For example, same time, same space is typically a location-aware game or event that takes place where students can learn, for example, with augmented reality. So we can have the technology fulfilling this same time, same space requirement. Same space, different time is, for example, a lab or a space in a university or a school where students come and can perform some activities like a lab or the Fab Labs that we have today in a fixed location. Then if you think about same time and different space, these are synchronous online events like the one we are having now. This means that students must be in the same timing. The time is the same, so it might not be easy for people who are living in different time zones in different parts of the world. And finally, we have different time, different space, totally flexible, the ideal way of our distance learning universities, which is online interaction, asynchronous activities, and events that might have serious games like in this example here. But this is a very simplistic way of creating a framework for instructional design. So we started creating our own model. We called it SLAM, for Science Learning Activities Model. So the SLAM model, and it has three basic areas. The first one is context, the second is technology, and the third is pedagogy. So these are the three pillars of our model. The context obviously relates to everything that goes around the society and organizations, knowledge, experts and peers, the tools and techniques. So everything that surrounds the learning environment each student or each organization has. Technology, educational technology, we are here concerned with what's happening now. So mobile learning, ubiquitous learning, the new interfaces, the new technology that is being imported into education, and this has to be addressed in this new model. Eventually, the pedagogies are also changing because of the context and the technology, and we see every year, for example, the Open University reports on pedagogy, which show reports on the pedagogies that are being tried, experimented each year. And some of them are sedimenting, are becoming a standard. And this might be scale, connectivity, reflection, extension, embodiment. There are many ways you can call these new pedagogies. So I will not go into this at the moment. But for context, in our model, we have three basic key factors. First one is formal to informal learning. These are continuous concepts. So these are the extremes of the continuum. So from formal to informal learning, we need to specify the topics, the activities, how they fit together in a set curriculum, going from formal to informal or non-formal, if you wish. The second key factor is individual and collaborative learning. And here we have to think, what must the student do by himself or in groups, and allowing eventually for the learners personal learning environments, what we call PLEs. The third key factor in context is the open to closed learning environment, going from very open to very restricted. For example, a MOOC is a very open and free learning environment, but we can have the SPOCs or small e-learning environments that are paid for and that universities want to keep restricted. So where do we manage our design, our instructional design within these constraints? The second aspect, technology, also has three key factors: synchronous and asynchronous learning. This is the time dimension in Johansson's matrix. So obviously we have to decide if we have chats or video conferencing, at what times, and what is going to onto flexible anytime, anywhere timing. And this has to be decided from the beginning as well. Then what virtual and physical interaction? This is the space dimension in Johansson's matrix. We have to set what is going to virtual, what is physical, what situation in the blended learning environment we are creating. And the third key factor is single platform to multi-platform. Most of the time you use only one learning management system, that means one platform, but we are now seeing that different platforms perform differently for different objectives. For example, Moodle, which is a traditional learning platform, but we have ELK, which is a more social-oriented platform, or Blackboard, which has other tools, or Edmodo, which is a free and very used platform for schools and for teaching. So the instructional design might need more than one platform, and as you can see, in a connected learning environment, we don't have to use just one way or one platform. Finally, pedagogy, and here we have four key factors. The first one is theoretical to practical pedagogy, which is very basic. We use this all the time. For example, from a learner-centered pedagogy, like the learning profiles, to more active learning models. This has more to do with the style of the organization, of the style of the teacher or the professor who is putting together a course, for example. The second key factor is the exclusive to open learning design. The activities can be very specific and very restrictive, or very open. If we talk about game simulations, multiple choice tests, these are quite restricted because we have a definite limited set of questions, for example, and you cannot change that much. This is a restricted environment. But if you ask students to create portfolios, essays, if they have to write reports, this is a kind of a very open activity where students and teachers can have some leeway, can be more flexible. The third point in pedagogy is centralized to peer assessment. So assessment can be very centralized, very restricted as well, like in many organizations. The students have exams, have tests, have specific ways of being assessed, or otherwise we can go for a very flexible way, like peer assessment. They assess themselves. There are mechanisms and tools that allow students to do peer grading or peer assessment, if you wish. And the fourth item is pre-structured and open guidance, going from also restricted and structured guidance way, let's say some guidelines that are set in the beginning, or an open guidance where students can help themselves among themselves. The teachers can go on helping them or asking them questions and getting feedback. So it could be very flexible. Scaffolding that's supporting the learning, also more structured or more flexible. This is probably the last item that we have discussed quite extensively, because it's not very easy to decide exactly how to structure this guidance. Eventually, we have problems with some of our systems. Some experiments we've done show that students don't get involved with the subjects. MOOCs have a very high dropout rate. Many learning courses we create are not very appealing. And I found somehow that digital storytelling comes and solves this problem in some areas, in some topics. That means creating a story where there are characters, there's a setting, a narration, and if you can make your course structured in such a way that is a story or a narration, that might come very helpful. Students are engaged with the subject, and eventually you get some good results. Another way is gamification. That's the use of game design elements in non-game contexts. We can use points, levels, challenges, badges, leaderboards, score tables. So the elements that we have in a game, and remember that these students were brought up with games. They are not the television students that I was. These students, they play games all the time. The younger ones, they were brought up with games. So why not using these devices as well in the right way? Because the problem is sometimes just is not enough just to bring in points or levels. There must be a structure that is sufficiently appealing and interesting and effective as well. Some game mechanics, dynamics, and the way to create emotions. This is a model called the NDE model. And you can have many kinds of devices like rewards, achievements, progress bars, quests, skill trees, more or less what you have in a game. With this in mind, we for example, we structure some of our courses at the Portuguese Open University, at Universidade Aberta, in a way that the multiple choice tests are somehow gamified with points and levels. Students have to answer, for example, specific questions about the subject. Here is a course on ICT, and then the system automatically gives them the answers, the right or wrong answers, and explains where they went wrong. But coming back to the main topics, there are some trends that I want to showcase, and we talked about the web technology, and this is the most accessible one, inexpensive and user-friendly, changing and developing all the time, and it's been used since the web exists. So it's interesting to know that the web is still alive. Mobile technology, just because students and teachers and everyone now are using smartphones and tablets and mobile devices, so it makes sense more and more that educational instruction also makes use of these devices. And then we have the third trend, which is going towards 3D, AR, VR. That means augmented reality, virtual reality, and these are more difficult to attain at the moment because of the limitations in the technology. Now I'm going to talk a bit more about this. So we have to think about this evolution, but with some caution. For example, games and simulations, they are expensive to create, but they can be very effective, and they are being used in any domain of knowledge, from medicine, health, to management, to any, like for the flight pilots as well. Any area now you can find games and simulations. Virtual worlds, there was a hype at the time that Second Life was very in fashion. It was about 2007, 2005 maybe. We tried virtual worlds in our university, for example. In this case, there is a visit of students. Each of these avatars is a student, a master student, and they are going to a virtual visit of the Roman ruins that exist in Portugal, a place called Coimbra. And we had some contests where students had to take photos. Of course, they didn't take real photos. They just did the print screens as photos, and then there was a contest to see what was the best picture. And this was a way of engaging students to know history and archaeology and how it was in Roman times. So we used virtual worlds for a while, but we are not using it these days. Another research that I've done with a project in Portugal is for deaf people. We had sign language learning, called a project called Virtual Sign, and here we developed a game, and the game made use of the Kinect and some sensor gloves in such a way that we could play the game using Portuguese sign language, and the system was recognizing the sign language, and we played the game if we knew, and we had to learn how to use sign language. And for that, in the project, we had to create a database with all the gestures. So the avatar would be connected to all these gestures, and we could communicate eventually with deaf people, and understand the gestures. It was not very perfect because it's very difficult to translate from text, for example, to virtual gestures. But we came quite close, like 80 or 90% of recognition of the gestures and translating into text, for example. The virtual sign game was quite successful among students, the young students. This is another project I was involved in around 2009 in the United States during a sabbatical. And in 2009, they were using what was called then the PDA. Now we would call them smartphones, but in those days, the PDA didn't have a phone. It was just a portable device. And with the PDA, we could play location-aware games. For example, in this game, Saving Lake Wingra, students would go around the lake, and they had to solve pollution problems, environmental problems, that were happening around that lake. They could perform as a landscape architect, a watershed ecologist, or an environmental historian. So their characters were one of these, and they had to find solutions for the pollution in each part of the lake, and automatically the app would be giving them hints and specific assignments. This game engine called ARIS is available. Anyone who wants to try and experiment with location-aware games can go download and install. This is available for iOS. Around 2011 or 2012, I don't remember. I started this idea of the GameBook, creating a book that was a game, because students know how to play games, they know what the book is, and we try to connect the concept of a game with the idea of the book. And we came out with an ebook that was developed with iBooks Author for the Mac. And there was a storyline. This was for young students, and they had to read the book with the story. And eventually, during this story, there were videos, for example, a video on YouTube that would be available by touching, And then after the video, they could solve problems and answer some questions, for example. Also in the GameBook, there were maps. This was a trip around along the river in Portugal, and they could open the map in Google Maps and that would show them exactly where the story was taking place. There were also puzzle games like this one. These are just scripts that we can introduce in an ebook, and they had to align these puzzles. And this is a flower that is typical of that place where they were traveling around. Of course, today we have more technology. We have augmented reality. Pokemon Go is typical of a location-aware game, and it's very common these days, as you know. But augmented reality is just not for fun, because it's being used in factories, by medical doctors, and here in the German Cancer Research Center in Heidelberg, they are using iPads with this kind of software for augmented reality. This is myself in Barcelona, in the Batlló house built by Gaudi, and what they've done was remove all the furniture from the house, and you can go around with the portable device, and you can see where the furniture was in that house. Because the number of visitors is so much, they removed everything from the house. So to see how it was when the owners were living there, you need to use the augmented reality application. These are students from a PhD that I teach in my university, and they created an augmented reality application for music teaching in such a way that students can look at the book, can study, and then if you point the portable device, the smartphone, you can get the music coming from the scores that are on the paper. So there is a relationship between the physical book and the virtual multimedia environment that is created through the augmented reality. Now, if we're talking about mobile, remember this experiment, Google Glass from Google. It was very elegant, but it didn't work out. Eventually, they finished with this idea. It would be interesting to see if this has some evolution. But now what is happening is I've just came from Austria recently, and they are researching with Microsoft HoloLens. In my country, we are starting now as well. And the Microsoft HoloLens is also an augmented reality system with cameras and video screens inside those glasses, and they can allow for augmented reality, and you can click, and the system can check your gestures. You can translate them into action. Just as you know, these goggles have Windows 10 just running inside them. Virtual reality is still in the infancy, I would say. It's very heavy, it's not very comfortable. Some people are using this, but it's not very portable as well, especially because of the cables that you need to use. And if you turn around a couple of times, you get tangled in the cables. So I'm just showing this because it's a trend. People are talking about virtual reality, and it might be very useful for education, for showing specifically models and objects that are difficult to grasp, but it's still a long way from being useful, and it's expensive as well. Less expensive, sorry, is the virtual reality by Google with the cardboard. You just have to buy these very cheap cardboard frames where you insert the smartphone, and you can have some kind of virtual reality, not very perfect, but it's very acceptable. So, coming to finalize this talk in thinking about the future, what we need is think about the learners and society, what they are doing in our society. And you can see they are always connected, in constant interaction, accessing fast information, making fast decisions, and integrating different kinds of media. So this is exactly what we have to think when we are talking about blended learning or mobile learning. Are we meeting these requirements from our society, our current society? Are we getting students exactly the same kind of response that they are getting from the companies and the organizations they are dealing with? So I think this is what we have to answer from now on, and my research is also going this way. So thank